So in this session, we will start the second part of Unit 1, which is about the fluid and the material. So first, we define the term density. How we define the term density? So density is mass present in a unit volume, and if you want to calculate a density of a material, the mass of an object divided by the volume will get the density. The SI unit of mass is kilogram, and for volume it is meter cube. So the SI unit of density is kilogram per meter cube, or it can be gram per centimeter cube, depending on the questions. So how we define the term density? Density is simply termed as the mass present in a unit volume. If we have more matter in a unit space, like example, two objects have the same volume but different amount of the matter, A is having more particles, more matter as compared to that of B. So when we compare the density of A with B, A is having a high density where B is having a low density. And it can be also refers to if two objects are there, they have the same volume, they have the same matter, same amount of matter, but they have different volumes. In this case, when we compare the density amount of matter present in a unit volume, like if we take a 1 meter cube volume for object A and 1 meter cube volume for object B, so we will find that for object A there is more matter in a unit volume compared to object B. So object A is having high density where B is having low density. So density is simply termed as the mass present in a unit volume. So when we define for fluid, we define this term density. So example, a bottle of beer containing 250 ml and mass of a beer excluding the bottle is 0.238 kilogram. What is the density? So how to find the density? Density is mass present in a unit volume. It is given in milliliter, ml. We have to convert milliliter into meter cube. So we have to divide by 1 million. Or 215 to 10 to the power minus 6 we can also say. So this will convert this into meter cube. So the volume is in meter cube and the mass is kilogram. So mass divided by volume will get the density kilogram per meter cube, which will come out as 9.52 into 10 to the power minus 4. Another example, 1 kilogram of a salt is poured into 49.8 liter of water, which make 50 liter of salt water. Find out the density of the salt. So we have to find the density of the salt. So this is a salt water, and this is a volume of the salt water, and this is a volume of the water only. And as we know, the density here, because the mass of the salt water will be equal to the mass of the salt plus mass of the water, and mass of a salt plus how to convert, because mass is equals to density into volume, so it will be equal to density of water and volume of water. So we have 1 kilogram of a salt, that's why we write 1 kg. The density of the water, which is 1000 kilogram per meter cube, multiplied by volume of the water. The volume of the water is 49.8, so here it will be 49.8 meter cube, because there was milliliter, but now we have liter. So if we want to convert liter into meter cube, we'll divide by 1000 or we'll multiply by 10 power minus 3. So this will give us the total mass of the salt water. So we have the mass of the salt water, and we have the volume of the salt water. Mass divided by volume will get the density of the salt water. Is it clear, this question? The second example, how we work out the density of the salt water. Any doubt in this? So first we calculated the total mass and divided by the volume of the solution, volume of the liquid, we'll get the density of the salt solution. Then understand the use of relation upthrust and weight. So what is the concept of upthrust? When objects are there placed in the fluid, like example you have a container and this container is filled with a liquid. So when we add the object, so the liquid will be displaced, this liquid will come out, so when we add an object, when this object is added to the liquid, there is a volume of the liquid, certain volume of the liquid is displaced, and that volume is equals to, so volume of the object is equals to the volume of the liquid displaced. So if object is example 2 meter cube, it will displace 2 meter cube of liquid. If object is like 3 centimeter cube, then it will displace 3 centimeter cube of the liquid. So when we measure the weight of the liquid displaced, like example, we add the object, when this object is added, the liquid is displaced, and we calculate or we measure the weight of this liquid displaced. So the amount of liquid which will come out, the volume of the liquid will be equal to the volume of the object. If volume of object is like example 5 meter cube, the amount of liquid displaced will also be 5 meter cube. And what about the weight of this liquid? Like example, if we place it on the balance, so when we place this on the balance and we measure the weight, say example, the weight of this liquid is coming out, only the liquid is coming out example 30 Newton. So what does it mean? What is the meaning of this 30 Newton? So actually the liquid is applying an upward force, that's called upthrust. The upward force, and it is always up, that's why it is called upthrust. The direction is vertically upward, so it is called upthrust. And how we know this value of the upthrust? The upthrust is actually equal to the weight of the liquid displaced. So what weight of the liquid, volume of the liquid displaced is same as the volume of object, and weight of the liquid displaced is equals to the upward force which is applied by the fluid known as upthrust. So example, if this object weight is 30 newtons, so if object like the weight of the liquid displaced is 30 newtons, so how much is the upthrust? The upthrust on this object will be 30 newton. So simply the definition of the upthrust is the vertical force, upward force applied by the fluid, and that is always equals to the weight of the fluid displaced. So as we know that upthrust is equals to the weight of fluid displaced, so upthrust is equals to the weight of the fluid displaced, and weight is equals to mg. So that will be mass of the fluid. We can say the upthrust will be equal to the mass of the fluid into gravity. And what about the mass of the fluid? The mass of the fluid is density of the fluid multiplied by volume of the fluid displaced. This is not the total volume. This is the volume of the fluid displaced. So we can say upthrust is equals to density of the fluid, volume of the fluid into gravity. And then, as we know, when object is completely submerged, when object is submerged in the liquid will come out. The volume of the object is equals to volume of the fluid displaced. So we can say the volume of the fluid is actually equal to volume of object. That's not the total volume. Again, I repeat, that's not the total volume of the fluid. It is the volume of the fluid which is displaced by the object. So we can write, and we can say upthrust is equals to density of the fluid, volume of object, and gravity. So this is how upthrust is calculated. If we know the density of the fluid and we know the volume of object or the displaced fluid and the gravity, so when we multiply these three factors, what we get, we'll get a force, and what we call that force, we call that as upthrust. Is it clear, the concept of upthrust? Any doubt? And same way, using the upthrust, we can also e- explain the idea whether the object will float or it will sink. How we can identify whether the object will float or sink? Using the upthrust and weight. So if the upthrust is more than or equal to weight, the object will float. Example, there's a container which is filled with a fluid, and we have an object which is having a weight of say 30 Newton. So when we place this object which is having a weight of 30 Newton, so how much volume of the fluid displaced, that will be equal to upthrust. So example, the weight is 30 Newton, but the upthrust of the fluid is more than 30 Newton, example 32 or 33. So as you can see, the upthrust is more than the weight. If upthrust is more than the weight, what we'll observe? We'll observe this object will float. And upthrust can be changed. Like that's how we can make these large ships to float. As we know, the upthrust is equals to density of the fluid, volume of object, and gravity. So gravity, okay, it's a constant thing, cannot be changed by, we cannot change, it changes according to position. Density of the fluid also, when we compare, it can be changed, but not in a large scale. For a bulk, like example, you cannot change the density of the water, sea water. It changes from place to place depending on the amount of impurity. So more or less it is same. It can change, but we cannot change it. So the only factor which we can change is the volume of object. So if we can increase the volume of object, what happened to upthrust? The upthrust will also increase. That's how they're making these large ships float, that they have a greater volume. So if they have a greater volume, they will displace greater amount of fluid, and as it will displace greater amount of fluid, the upthrust will increase, and as the upthrust increases, the ship will float on the surface of the water. Same way, if we have an object, another object is there, So there's another object which is having a weight of example 40 newtons. So when we place this object in the fluid, because a 40 Newton weight is there and 32 Newton example if it is having the same material but different, relatively different size. So example 33 Newton is a upthrust. So as you can see, the upthrust is less than the weight. So this object will move towards the bottom, or this object will sink. So floating and sinking depends on the upthrust and the weight. So if upthrust is less than the weight, the object will sink. Is it clear? The concept of upthrust and floating and sinking, how we can make the object rise or float, or how we can make the object sink depending on the value of upthrust. Same way the hot air balloons, how the hot air balloons can rise. So example, this is a hot air balloon and at the bottom there is a burner is placed. There's a burner here. And what is the fluid here? Fluid is air. What is the meaning or concept of the fluid? Fluid means something which can flow. So both liquid and gases are termed as fluid. And here the balloon is a object. So what happened? The weight, if the gravitational field is not changing, because mass of or amount of matter is same constant, and if the gravity is not changing, it can change with height, but example if the gravity is constant, so the weight will be constant. If we want to make this balloon, hot air balloon, rise from the surface, example it is on the surface and we want to make this hot air balloon rise. So how it can rise? When we switch on the burner, we supply the heat energy. So the moment we supply the heat energy, when we supply the heat energy, we know the upthrust is equals to density of the fluid, that is constant, density of the air, that's the surrounding air, which changes with the height. Again we repeat, it's not constant, but if we assume at a certain height it is constant. So density of the fluid, volume of object, and gravity. So the moment we switch on the burner, we supply heat energy, and because of that, the air which is present inside, the gas which is present inside will expand. When it will expand, the what happened? The volume will increase. So as the volume increases, the upthrust will also increase, and in that case, the upthrust will be more than the weight. So as upthrust is more than the weight, there's a resultant upward force is there, and due to this resultant upward force, this balloon will rise. Is it clear? This example, how we can use the upthrust, how we can change the upthrust to make the object or hot air balloon rise. Any doubt till this point? So as you can see, different scenarios. The first one, the weight is more than the upthrust. If weight is more than the upthrust, then the object will sink. If weight is balances with the upthrust, there is no resultant force, so object will remain at its position. And if upthrust is greater, then the object will rise. then you should be able to use the equation for viscous drag or the Stokes law. So what is a viscous drag or a drag force? The force which opposes the motion, the force which try to resist the motion in a fluid, the force applied by the fluid to stop the object moving, that force is known as the viscous drag. And according to Stokes, it is given by a formula 6 pi eta rv. That's a formula. So when object is there, and this is only valid for spherical object. Like you have a sphere which is moving through a fluid. So we have a large container which is filled with the fluid, and we drop an object. So when we drop an object, when the object is moving through the fluid, or this object is there in the fluid and it is moving downward. So what are the forces acting on this? Number one, it's weight which will act downward. Number two, the upthrust, and because it is moving downward, so it means upthrust is not sufficient. Upthrust is smaller than the weight, that's why it is moving downward. And what about the third force? So there is the force of the fluid which try to stop or which try to resist the motion, and the direction of that force is always try to oppose the motion. So if object is moving down, the viscous drag or the drag force will act upward. So there is a viscous drag or the drag force will act upward and weight will act downward. So we can say this force is known as a drag force, also known as the viscous drag, and the direction of the viscous drag is to oppose the motion. And what is the formula to calculate this viscous drag for a spherical object only? So for spherical object, the viscous drag is given by a formula 6 pi eta r v. 6 and pi are the constant, but what about the eta? What is the meaning of this eta? This eta is known as viscosity. And what is the meaning of viscosity? Viscosity means property of a fluid to resist the flow. Like when the fluid does not flow easily, example, if you have two containers, one is filled with water, another one is filled with honey. And when you transfer them, equal amount of two liquids are there. And when you try to transfer them into another container, so you will find that honey is taking more time to flow as compared to that of water. So we say honey is more viscous, or it is having a high viscosity. And the unit of the viscosity is Pascal second. So this is viscosity, the property of a fluid to resist the flow. Higher viscosity means the fluid will move slower, it will take more time, where r is the radius of the object. And what about v? V is known as the terminal velocity, or not specifically terminal velocity, you can simply say velocity or speed. It will be terminal velocity if the resultant force will be 0. So this v will be refers to terminal velocity if the upward force like viscous drag plus upthrust is equals to weight. So means there will be no resultant force. When no resultant force, that constant speed will be the terminal speed. But sometimes the speed is continuously changing, so we don't call that as terminal speed. So the concept of the viscous drag is the force which opposes the motion of an object when it is moving through a fluid, and it is given by a formula 6 pi eta r v. and it is only valid, like this formula is only for spherical object. If you have, like example, a cylindrical object moving through, or a cube is moving through, we don't use this formula. This is only for spherical object, and it is only valid. What is the condition? That very small sphere should be there with a low speed. So if a large sphere is there, a very large sphere is there, then this formula is not valid. Or if the object is moving very fast, again this formula will not be valid. So example, using Stokes law, calculate the viscous drag or the drag force on a sphere having a diameter of 5 millimeter. The speed is 2 millimeter per second, and the viscosity is a property of a material to resist the flow, and this viscosity is not constant, it changes with temperature. For liquid, when we supply heat energy, the viscosity decreases, so liquid can flow. That's why here a temperature is also mentioned. At 20 degrees, the viscosity is 1 pascal second. So we have the formula F is equals to 6 pi eta RV. When we substitute the values, so this is 6 pi is 3.14 R, the radius, so 5 millimeter. We have to convert into first into meter. So we divided by, uh, we multiplied by 10 power minus 3, or you can divide by 1000. So that is, and then divided by 2 to get the radius, because radius is half of the diameter. Viscosity is 1.5, and speed at which it is moving, that is 2 millimeter per second. So 2 into 10 power minus 3 meter per second. So when we multiply them, we'll get 1.27 into 10 power minus 4. So that is a viscous drag or the drag force. Same way, if an object is rising through a fluid, like the first example, the object is moving down. But it may happen, like example, we have a bubble which is released at the bottom of the fluid, and it start to rise. So there is a bubble which we release, and that is moving upward. So in this case, the weight is acting downward, the upthrust is acting up, and because it is rising up, so it means the upthrust should be more than the weight. That's why it is rising up. And then what about the viscous drag or the drag force? Because that always opposes the motion. So in this example, the viscous drag or the drag force will be downward. So when we write the equation, we'll say that upthrust is equals to viscous drag plus the weight. And the previous example, upthrust plus viscous drag was equal to weight, because the object is moving down. So it depends on the question how the object is moving. And if the object is moving with a constant velocity, what is the condition for object move in a constant velocity? When there is no resultant force acting, that time the object will move with a constant velocity. So in that case, resultant force will be 0. Then we have a fluid flow. When the fluid, like liquid and gases, flow, so their flow can be refers to a laminar flow, or it can be refers to a turbulent flow. What is the meaning of laminar flow? Laminar flow of a fluid means when the particles are moving slowly and they do not cross each other. The particles which are coming from back are following each other. So this kind of a flow, like particle A particle B, C, D and E, they move one over the other like following each other. We call this flow as a laminar flow. But what about the turbulent flow? When the particle actually cross each other, they move at a high speed, changes the direction. So we call that flow as a turbulent flow. So on the picture you can clearly see when the water is falling at the top at a certain height, it appears to be a very calm movement of the fluid or water. So we call that as a laminar flow. But when it is coming down, it spread and the particles moving randomly. So that flow is refers to a turbulent flow. So a fluid can have a laminar flow or it can have a turbulent flow. What happens in a laminar flow, you should be able to distinguish. The laminar flow velocity may be different at different places, but at a given place, it is constant. What does it mean? Like example, so these are the particles which are following each other, and these are the particle, another group of particles which are following each other. So the particles which are moving here and the particles which are moving on the other side, they may have different velocities. But for this section, the velocity will be same. Like example, at this point, these particles are moving with 5 meter per second and 5 meter per second. But this section, this area, the speed of the particle when they are moving is same. And when we calculate, this is example 10 meter per second, 10 meter per second, 10 meter per second. So for this section, the speed is same for the particle. So here particles are moving slower, here particles are moving faster. But for the section, for that specific region, the speed of the particle is constant in a laminar flow. But what happened in a turbulent flow, even in the same section, the particles are moving at different speeds. So if these are the group of particles, so what happened? Maybe this is moving with 5 meter per second. This might travel with say 6 meter per second. This is traveling with 2 meter per second. This might travel with 8 meter per second. So in the same region, the particles have different speed in a turbulent flow. So that's the first difference, that laminar flow, particles may have different speed, but at a specific region or a place, they have a same speed. And in a turbulent flow, there's a sudden change in the speed, and these are called eddies. But in laminar, there's a smooth, no sudden change in the speed. This normally occur when the fluid is moving at a slow speed, and this normally occur when a fluid is moving at a high speed. And it normally associated with a small resistance, like when this fluid is applying a small resistance, the flow of the fluid around the object will be laminar. But when fluid is applying greater force, it's associated with a greater resistance, like when object is having a large area, so the fluid will apply more resistance and the fluid flow changes to turbulent. So example, like slow water which is flowing along a smooth pipe, and air which is moving or flowing in the storm. So we can use this concept to explain the idea how a plane can fly by using these fluid flow. So what happened? Like example, this is representing the wing of the airplane, and airplane is moving towards the left hand side. So if airplane is moving towards left, the fluid will move from in opposite direction, it will move from left to right, because to lift the aircraft, weight is acting downward, so it need a lift upward. So during a takeoff, the position of these flaps which are there in the wing, so the position of the flap changes. When the position of the flap changes, like it increases the surface area, So at the bottom, there is greater air resistance as compared to that of the top. So when at the bottom there is more air resistance, at the bottom there is more air resistance than at the top. So what it provide a resultant upward force, and due to this resultant upward force, the aircraft lifted up from the ground. So the fluid flow is very important, that adjusting a fluid flow, the aircraft reach a certain speed, and the wings having a flaps which adjusted the air pressure. So below it will have greater air pressure at compared to that of top. So it will have a large air resistance which increases, make the turbulent flow. And when there's a turbulent flow, there's a greater force, so that create a resultant upward force. And when there's a resultant upward force which is more than the weight, the object will lift. That's how the aircraft lift at certain speed. And for landing, what they do, they adjusted the flaps. For the landing, they adjusted the flap so that there will be a large air resistance from the top. So when there is a large air resistance from the top as compared to that from the bottom, there is more downward force than the upward force. If there is a greater downward force than the upward force, so what will happen? This aircraft will land. So this is how landing or takeoff for the aircraft is managed by adjusting the fluid flow. Is it clear, this example, how a fluid flow is essential for landing and taking off for the aircraft? Any doubt till this point? So the viscosity, the property of a fluid to resist the flow, we call viscosity, and that changes with temperature. So you can see at different temperature the viscosity of air, the viscosity of the water, and viscosity of glassine. Here liquid air is a gas, water is a liquid, glycerine is a liquid. So you can see for liquid, when we increase the temperature, the viscosity is decreasing. But for gases, when we increase the temperature, viscosity is also increasing. What is the reason? Because for gases, the particles are moving randomly. So when we increase the temperature, so the moment we increase the temperature, the particle will move faster. So as these particles move faster, that's why they are not able to flow. Random motion increases and the flow decreases. That's why for gases, as we increase the temperature, viscosity increase. But for liquids, it is opposite. That increase in temperature reduces the viscosity.